Okay, this chapter is about matter and change. Also in this unit, besides matter and change, we are going to cover isotope notation, which is in a different PowerPoint, as well as binary molecular naming, which is in a different PowerPoint. So this is only one of the three PowerPoints for the next test. So first of all, matter can be subdivided into either a mixture or a pure substance. Now, matter, as I'm sure you know the definition, is anything that has mass and takes up space. So mixtures and pure substances both qualify to be matter. A mixture can either be further subcategorized as either heterogeneous or homogeneous mixture. And a pure substance can be further categorized as either being an element or a compound. So over the next few slides, we're going to talk about what makes something a mixture compared to a pure substance, and then also distinguish between heterogeneous and homogeneous mixtures, as well as tell the difference between an element or a compound, which I'm sure at this moment everybody in this class should know the difference between an element and a compound, because we have been working with those since the third day of school. So a phase. So we're going to be talking about different phases of matter. And a phase is a physically distinctive form of matter, such as a solid, a liquid, a gas, or a plasma. A phase of matter is characterized by having a relatively uniform chemical and physical properties. And most students come in knowing 4 of the states of matter. In elementary school, they teach you the 3, solid, liquid, and gas. Then they should add on plasma sometime when you are in the middle school. Actually, most of the matter in the universe is in the state of matter of plasma, because it is what is found in outer space. So the sun and different planetary celestial bodies are made of plasma. The only plasma on the surface of the Earth is found in our ionosphere, and is lightning, for the most part, is the main plasma state of matter that is on the surface of the Earth. But there are many more different states of matter. Some of them were discovered on the quest to find absolute zero, and others are, as we have learned more about different technological advances, different states of matter have been discovered, as well as in our investigations of outer space, other different states of matter have been discovered. So, as we said, you could either be a mixture or a pure substance. That's the first division in matter. And a mixture is just a physical blend of 2 or more components. Their composition is not fixed. One sample of the substance is not identical to another sample of the substance. And it can either be homogeneous or heterogeneous, depending on the distribution of the particles throughout the mixture. A pure substance is a material with a fixed composition. So that's the opposite of a mixture. A pure substance does have a fixed composition. It has a set chemical formula, meaning that it is the same all the time. So if we said a pure substance like copper, its formula is Cu. That's always Cu. You could have salt, NaCl, but that salt is sodium chloride. So it has a set chemical formula where the ratios of the components that make it up are exactly the same. For in the case of NaCl, it's 1 Na for every Cl in every molecule of table salt or sodium chloride that you have. It can be a compound, or it could just be a single element. So a pure substance can just be a compound, like the element copper, or it could be, it could be an element like the element copper, or a compound like sodium chloride. So it can be either one of those things as long as it has a fixed composition and a set chemical formula. So a compound has two or more elements that have been chemically combined together. For example, H2O or CO2, or our previous example of NaCl. They have two or more elements in them, and that those elements have been chemically joined. There are currently 118 known elements on the periodic table of the elements, and some of those are synthetically made, which meaning man-made in the laboratory, and others are naturally occurring. An element is the simplest form of matter and the smallest, it should say, amount that still retains the property of the element is an atom. So if you just have one of that particle, one of those elements, it's an atom of that material. And we know the elements on the periodic table because we've been given a list. There's 118 of them. So if somebody asks, is this thing a compound or an element? If it's on the periodic table of the elements, it's an element. And if it's not, it could still be something other than a compound. But if it has a chemical formula, then it's a compound. One type of pure substance that can be broken down into a simpler substance is a compound. And it is it's more than one thing chemically combined together. Compounds don't retain the chemical properties of their individual components. So if we talk about sodium, for example, sodium by itself is a soft, whitish colored metal that's super easy to cut. And chlorine is a yellowish gas that is poisonous. These two substances together are very different than when we combine them together in a 1-to-1 ratio and make sodium chloride. That's table salt. It's what we put on our food. So the two substances, when they're separate, are very different than the compound that they make up. Another type of substance that can't be broken down into a simpler substance is called an element. And you, once again, will know you have an element if you can find its name on the periodic table. All the substances of the universe are either elements or compounds formed from these elements, or mixtures of the elements and compounds. So these are some examples of pure substances. So gold, that's an element. It's a pure substance. Copper wire, that's an element. It's a pure substance. Sugar has a chemical formula, so it's a compound. Salt has a chemical formula, so it's a compound. Hydrogen gas is an element. Diamond is made out of supercompressed carbon, so it is an element. A pure substance is matter, either an element or a compound, with the same fixed composition and properties. Compounds are more than one element, and like I said, the properties of the compound are different from the properties of the element that make it up. So if I had silver, you know what silver looks like. It's a silverish colored metal. And then if you have bromine, which is a liquid brownish color solution at room temperature. And silver bromide is a yellow powder. So it's totally different and has different properties than the silver and the bromine when they were separate. Mixtures, on the other hand, are not pure substances. Mixtures can either be heterogeneous or homogeneous. A heterogeneous mixture means the composition is not the same throughout. That's what the prefix hetero means. It means different, not the same. Homogeneous mixtures, which are also called solutions, are the same throughout. So a heterogeneous mixture has two or more phases in it, generally speaking. And a homogeneous mixture, the reason it's called a solution, is everything is uniform throughout. So it's usually a liquid. So that's why the name solution. So we've got different heterogeneous and homogeneous mixtures here. A homogeneous mixture is a mixture in which the components are uniformly distributed throughout its volume and they cannot be seen separately. You can't visually see the difference in the components when you're looking at it. Whereas a heterogeneous mixture is a mixture in which the components are not uniformly distributed throughout. Its volume can be seen and separated. Typically, heterogeneous mixtures can be physically separated by hand or with a tweezers or some other means to easily separate because you can see the difference. Okay, homogeneous mixtures, you cannot see them evenly. They're evenly distributed, so you cannot see the individual components, but they can still be separated. So there's some separation methods here. So you can separate something that's magnetic and non-magnetic if they were mixed together using a magnet. You could separate something that was liquid and something that was solid with filter paper in a filter. You could separate two different size particles, a larger size particle and a smaller size particle, with a sifter. That's what this picture is. It's not a decanter. This is a decanter. This one that's over, that has this two sides, two separate sections, and that would be when you were separating things that had two different densities. So the denser of the two substances would go to the bottom, and you could separate off the densities. Evaporation, you could separate off two different mixtures, something that was a liquid and something that was a solid, by evaporating out the liquid. And you can centrifuge to separate. Usually centrifuge is used to separate the different components that make up blood samples. It's separating things by, once again, based on their density. You can distill something. Distillation is using a evaporation condenser that separates a liquid with two different boiling points. So you can use distillation. And you can use chromatography to separate out the pigments that are found in some sort of solution. A mixture is a combination of two or more substances in which the basic identity of each substance is not changed. Unlike pure substances, mixtures don't have specific compositions. So let's see if we can fill up this chart using our key of words up at the top, our bank of words. So the main category is matter. Matter can be subdivided into either a mixture or a pure substance. Pure substances and mixtures can be further subdivided. Mixtures can be divided into heterogeneous mixtures and homogeneous mixtures. And pure substances can be divided into compounds or elements. That's where we're going to end today, and we will talk more tomorrow.